is what you see there. Times R minus D over U minus D plus CB times U minus R over U minus D. Where is P? There is no P, which is exactly, from those of you who've seen the Black-Scholes, this is exactly the reason that in Black-Scholes, the drift of the underlying asset is not the expected drift, which could be contingent on the probability of going up and probability of going down, but the risk neutral drift. This is a very, very deep thought. I mean, all the Black-Scholes follows from that, and it's not even an original equation. Black-Scholes equation is exactly the same as the heat diffusion equation in metals. Black-Scholes equation existed. It's this thing here. Essentially, they said, we will value options not as entities in themselves. We'll value options contingent to the fact that these probabilities are all integrated in today's price S. Because if this is a very high number and this is a very low number and this still is S, it means that the market is very risk averse. This risk aversion has to be priced somehow into the value of the option. Through the back door, this risk aversion is priced into the value of the option. How? By eliminating P and 1 minus P. They don't exist. So if I'm very risk averse and this has a low value, then the option will have a low value. The value of the option will not be any higher because this is a high number. So, option, independent of elemental probability. That's the beginning of modern finance. Think of real options. A real option decision analysis. A real life problem. I plan to invest in a plot of land. Next year, I can choose to construct an apartment building or not. My decision next year will depend on the price of apartment next year. How much is the plot of land worth? The plot is my option. Future prices of apartment buildings are my US and DS. Building cost is my K. I assess the probability for an upstate of the world at P, for a downstate of conference P. For simplicity, R equals 1. There are no interest rates. Mainstream decision analysis would suggest that the plot valuation would be of this form. The probability that I live in an up world, and if this up world gives me incentive to develop, I develop, and the probability that I'm in a down world, and the down world, if it gives me an incentive to develop, I develop, otherwise, most likely it won't, so I don't develop at all. In mainstream decision analysis, this depends on P. You remember, we did that. I didn't see any one of you protest when I said, here, what is the expected value of this? We took probability adjusted and just propagated it backwards. So who is right? This is a very real problem. Who is right?
Which one is right?
They got it.
Even the option theory says my option value, my value of the, in this case of a plot of land, is not dependent on the probabilities, the elemental probabilities. Mainstream decision analysis says it is. Yes?
It has to do with the kind of the problem, with the assumption we took at the start, I think. The assumption with I can buy and sell all
exactly.
Something like that.
Exactly. This is very good. Exactly. What in here, in basic Black-Scholes, what is the very basic assumption? The very basic assumption is I have a complete market. Okay? I can buy and sell the underlying at unlimited quantities. That's why I can make this replication theorem. In the case of the plot of land, what would market completeness be?
I can buy infinite land.
No, the land's my option. What's my S? I can buy infinite apartments.
In the land.
I can buy or sell infinite buildings.
Oh.
The building is my asset, the plot of land is my option.
Oh.
So what the decision analyst, I mean, I have a personal view here. I have a personal view that the option theory is the correct way. And what the decision analyst should do, they would say not just that, but how much would the plot of land cost? What's the value of the plot of land? Given that in today's market, these elemental probabilities up and down of the building values, they collapse into a spot value for the price of apartment buildings of S. That means if the market is so risk averse, the real estate market is so risk averse as to still keep prices of apartments at S now, even though US is very advantageous and PR is very high, this means that this has to be built in the price I'm willing to pay for a block of land. Okay, the risk aversion of the market. This is again my personal thoughts. There is a great book by Lenos Theodorakis on real options. If you want to go, this is a whole other world of risk management. It's outside market completeness and the Ito process and when you go into like real non-financial situations. Lots of the same tools. There's a great book by Lenos Theodorakis, and it's something very interesting. You won't be tested on that. It was just, nice way to close the lectures. What happens when my risk attitude is very different from the risk attitude of my peers? What happens if I'm risk neutral in a risk adverse world? Generally, who is risk neutral in a risk adverse world? Can you think of an industry? How about insurance? This is exactly the play that insurance providers play. They are risk neutral. You are risk adverse. That's how they can make money out of you.
You can make money
because you can sell downside protection at a value which is much higher than its theoretical value, because the other guy is risk averse. Now, in the financial world, what is close to insurance? Option writing.
Insurance.
Exactly.
Yes.
Looks exactly like insurance. Credit. Credit protection.
CDSs.
CDSs. So things start to tie in at this level. It's interesting. Okay. This is it. This is the material. There's going to be no more material. You got office hours on Wednesday. We've got one last preparation session on Thursday. And you guys were a great class. Small but good.